back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. You can go to soten.z.dev to learn more about the project. We've been working on the clock tower. I spent a little more time looking at harpies. Sorry, I've been gone for a couple days. Family in town. I want to make sure that I'm fulfilling my familial obligations. Call your mom. She misses you. If you want to know, see what we've decompiled so far, you can click the source code link that'll take you to GitHub. And you can chat with us on Discord too. I've had a message up for the past, 24 hours or so, trying to phrase how I need some help, but I have trouble asking for help. If you have trouble asking for help, just do it. You have friends who love you. So, like I said, we've been working on Clock Tower. I did spend a little time on a harpy match. I'm going to talk a little bit about that, and then well, I think we'll get into a little more Clock Tower stuff. I do need to, the Clock Tower initial import was merged in, and so some of the things that have been decompiled so far, we can start integrating those back in, which I think would be helpful. There's some issues that we have to deal with there that are worth looking into, but let's get going. So, harpy. So we had a match for the PlayStation Harpy, and everything is building with that, no problems. I do have some issues right now. What I have in my local source tree has diverged a little bit from decomp.me, and I'm not sure which one is the most up to date at the moment. However, on PSP, I left it with some register swaps that I said I'll go back and fix those later, and then never did. And so I was looking at those last night, trying to figure out, actually yesterday morning, trying to figure out what might be causing these register swaps. So sometimes we'll see this, the V1 register should be used, but we're using the A1 register, A2, V1. These are all registers that are frequently used for temporary values, and the compiler's free basically to use. All the registers work the same. There are some conventions with MIPS, however, that usually compilers try to respect. There's something called an ABI, application binary interface, and so if you're using different compilers and want to link code in together, there's certain expectations that should be followed within a single compiler, though it's not as important to follow those conventions as long as the compiler is consistent with itself. The A registers are typically used for arguments, and there are, I'm going to get a graphic here that we can use. One second. I think this was the initial set of registers, which will be relevant for this. Oh, look at how lovely that graphic is. It's probably made in the 90s. So we have only 4 A registers, and so if your function takes more than 4 arguments, or your arguments are larger size than 32 bits each, those have to spill over to the stack, and the arguments are passed that way. T registers that are used for temporary values, and we have some comments over here about what that means. That means that when you call a function, the function is free to use these T registers for whatever it wants, and you can't expect them to be in the same state when that function returns. So this says not preserved across calls. Sometimes you'll hear the phrase caller saved registers. That means if the caller wants to retain these values, when the function returns, the caller has to save them and then restore them later. There's the S registers, which are typically used for variables, and these are callee saved. That means when you call a function and return, those registers will be put back to whatever value that they had. A couple more temp registers that ended up further down in the numeric order. K registers, we don't really see those in what we're doing. The GP register, typically don't see that either. The stack pointer register, anytime something's pushed to the stack or popped back from the stack, that is updated. FP we don't typically see, and then RA is the return address for the function call. So I guess also to note, there are 32 registers, 5 bits. Most of the fields that take a register as or most of the instructions that take a register as an argument use that 5-bit field. Just for that, the 0 register is always the value 0, and so something like a no-op, you can give an instruction format, and the 0 register is exactly that. V0 and V1, those are used as return values. Somewhat interestingly, you can have multiple return values. Usually an integer size return value is all that you get. If I don't know what the convention is for returning values that are larger than integer size in MIPS. I'm assuming stack space is reserved for something like that. And you would have to know what the function signature is to reserve that space. The at register is interesting, and we see some warnings frequently regarding the at register. There are certain things that GCC will do where it uses the at register and then the linker complains, and we get warnings during the build. And to disable those, it's bizarre, but to disable those warnings is kind of a pain in the butt. So we just live with the warnings, which is not the best place to be. Anyway, so those are all the registers and what the conventions are for them. There are a few additional registers that aren't listed here. One is called high and one is called low, and those must map, maybe they're mapped to K0 and K1, I don't know offhand. Let me see if I can figure that out. No, you have to, they're only accessible through the MF high and MF low function. Those are usually used for floating point instructions. We don't have floating point instructions, but we do have access to those registers through those instructions. When I say we don't have floating point, we don't have that on the PlayStation. So that's what the registers are. So within a function, though, when you're not calling another function, you can kind of use the registers for whatever you want, as long as by the time you call a function, they're in some consistent state with the expectations caller saved or callee saved, depending on what the register type is. And so things like V1 are frequently used as a temporary register because we usually don't have more than 32 bits of return value. And how those registers are allocated to different things depends on how the code is written, and then the compiler comes in and decides what registers it's going to use at which times. It has to keep track of whether a register is in use or is now free, and does so accordingly. And what we're trying to do when we're reproducing this code or building this code is get the compiler to behave exactly the same way that it behaved when Konami was compiling this. And so we need to structure the code to get the compiler to behave the same way. And something is happening where that is not occurring, and it's not clear why at this moment, but we do see this from time to time. And when that happens, sometimes there's things we can do about it, and sometimes there's not. And in this case, I'm struggling to figure out what the things are that we can do about it. So here we're moving this value into the A1 register. Oh, I have one idea here, and that would be providing a function signature. I think I've tried this before and it didn't work. Let's actually pretend move entity takes an integer. It doesn't, but let's pretend that it does. We probably won't move a value into A1 here. Oh, now we don't match. Let's give an empty argument list. An empty argument list actually, and it still shows up as A1. An empty argument list, unlike most programming languages in C, means that it takes an arbitrary number of integer-sized arguments. That's not... I don't think modern C means that anymore, but old C does. If we specify void, that's how we say that it's a function that takes 0 arguments. And this is a void, but that didn't affect the registers here at all. I'm a little surprised. So the A1 register usually is used for the second argument. Not sure why it's being chosen to be used here. So the other thing that we'll see is comparisons, especially greater than equal to or less than equal to comparisons. If we can find a value, let me find one, like this rotate down here. Usually greater than equal to can be written as subtracting 1 from that value, and we'll get the same. Oh no, it actually was already adding 1 to the value, and we'll get the same immediate value over here. But sometimes this can change the registers that are being used, and that's frequently what I will do to try to fix these register swaps. And we did actually see a bunch of them. Let's put that back the way it was. That gave us a significant number of more incorrect things, and M2C will put the not the comparison, I can't say the wrong comparison type. It'll put the comparison type that we don't necessarily want in there from time to time. So I've been going through this, trying to look at the comparisons that are in here. Sometimes they're nearby and related to the code that is using the wrong registers, and sometimes it's not anywhere near. Oh my goodness. Is this it? Did I just miss this one? This is the fun thing about streaming, is you, from time to time, come across exactly what you need. And there it is. 347 down here is going to be a button, so we don't need that. So I've done a lot of hand wringing over this, and it ended up just being related to that one comparison, and where that comparison was nowhere near where all the issues were. So we have this solved for PSP now. Let's let's see if we can get it to build for both. Make sure that this is still working fine over here. And it is. I was trying to, the other thing I wanted to do was, I do need to change this. I'm going to go back one. There's an include that we can use for the last case, and so I don't want to, can't keep this quite the same. Which stinks. It's nice being able to just copy and paste entire functions, but in this case I do have to piecemeal it. So let's build that. So that's building for the PlayStation just fine. I don't have my simultaneous platform build in yet, so I will have to do this separately for RP on the PSP. And so that's one of the things I think would be worth working on today, is trying to finish off Harpy. I know we started on on the Cloak Knight, and maybe we can finish off Cloak Knight and then go back to Harpy. All right. I'm going to change this to NZ1. And then build the PSP, and hopefully this works here. I haven't tested this. I don't know that I have all the symbols quite mapped yet, but we'll give it a shot and see if it goes. And it'd be nice if it did. So we can't use the same file for both of the platforms until we have... let's see if there's any errors. I don't see any errors specifically for this. Until one version of the game has all of its include ASMs gone, we can't. Specifically, the PlayStation version needs to have all of its include ASMs gone. The way that the MetroWorks wrapper, how it does the injection for the include ASM, doesn't respect if-defs, and it's a kind of a hard problem to solve. So it is an issue that's slightly more complicated than I was hoping. Unfortunately, VBIN is probably not gonna be the best here. So there is still a problem. Let's quickly just review the remaining differences over here and see. I can also do an export and make sure that I have all these symbols mapped correctly. Let's do that. We should basically get a perfect... I'm gonna undo this. That's really fine. Ooh, middle click works again. Life is good. Trying to think of what else I need to get this going. There is some context that I need. Okay, so something is very... Oh. Oh, my harpy function is wrong. So symbol for harpy is incorrect. Rat. So that that seems to be the issue there. Yeah, I just have the wrong offset for the harpy. Let's find the right offset for the harpy. And then, well, that is embarrassing. So we have sound effect 601, which is used in a couple places. Let's try 6AF. So harpy dagger is actually harpy. So all of these may be offset by 1. So this is gonna be a pain. Rat. Oh, this is one of those gut punch moments where you have to go through and fix a bunch of offsets. It shouldn't be too bad. Just have to be a little careful doing it. So let's do this. Let's grab... first we're going to grab 8B10. And we're going to throw what we're currently calling entity harpy into that file. What's currently called entity harpy at this address. That's going to be our function here, func PSP-EU. And we're still going to have entity harpy, but we need to update the symbol table. And we'll do it over here. Let's... Entity harpy is going to become entity harpy dagger at 7250. That's going to be our new starting point for entity harpy. And then we need to pull up one function from... Oh, I did this the wrong way. This function from 8B10 is going to come up to entity harpy. So this function, or this file, actually is going to go away. And we'll go to 60. It's going to get this function. Make sure we have it in the right place. 60. And then we need to update the symbols. Symbols US. STNZ, not US. PSP USTNZ1. Entity harpy. Odd that this was so off. So entity harpy is going to be wrong. So feather, we don't know what that function is. We'll find that in a second. But kick is going to be feather. Flame is going to be kick. Dagger is going to be flame. And harpy is going to be dagger. Okay. We're good so far. And so then we need hey, Original Dizzic, good to have you back. Then we need to grab what the address was for that 810 or 8B10. We only have one function there. Grab that address. Oy. And assuming I did everything right, which is a pretty sus assumption. We should be able to build this. Let's see. Oop, not the... Sure, I'm building the EU one. And what do we have? Anti-Harvey Feather does not exist. Oh, yeah. Wrong. Gotta get rid of this split. And get rid of the... It would have recreated that... that file. So this is building again, and I think everything's good, copacetic. So we can try this again and see if it's going to work this time, and hopefully that's the case. A good thing to solve. Okay, does it? No worries, no worries. It's been an odd week for me, so I was here on Monday, and then unexpectedly, I had family in town. Didn't expect to take off Tuesday and Wednesday. Let's see if that works now. Still not working. Harpy Dagger change, that's fine. Do we get any... No warnings or errors. We're 128 bytes off. Let's see where our first failure is. Unfortunately, yeah, it has to do with pointers. We have to look around this, probably around 7250. Offset 7250. 7250. We'll put a couple zeros in front of that to make sure we're going to the right place. Oh. We don't... There aren't any... So our first issue is here 7370. Let's try the decomp.me again and make sure that is we have the right address. Maybe I'm just completely wrong on these addresses. That would suck, but this looks better. And I'm expecting most, but not necessarily all of the symbols to match now. So screwed that up. Copying the entire context over. It's easier than just grabbing a few things. And then all the source. And yeah, like I said, I think I should have most symbols. Yeah, so this is pretty close. And occasionally we'll see things like this, G entities being incorrect. That's okay. We know why that is. Yeah, that's fine. That's fine. 347 is, oh, why am I not getting in? Nope, that's fine. was thinking it's the include that's here, but that's okay too. Possibly there's some RO data. Yes, I have some RO data that is not mapped correctly. So let's figure out where the charl is. We can map that. I don't know if there's going to be other RO data here. I don't want to focus on this right now, but when I get into a issue, and if I leave it undone, I won't get back to it necessarily. So we're going to do a grep for this charl. This is part of debug. We see it quite a bit. We need to find the one that we need for the printf. What is our function called? Font print. So this is the RO data that we need. Actually, we can stay on this tab. So this is, oh, this is nice as well. As far as I know, this is the only RO data, and it is right at the end of this file. So I think we can take this and split on that as well. Get it one more time, 254C8. Oh, but this ends up being just in data. That's interesting. In not here, 25. In GCC, strings like that would be part of RO data. Make sure that this is where Harpy is, in between ST update and particles. Oh, before particle. Okay, that works for me. Let's try it again. Hopefully that's all it was. Yeah, there we go. We got it. Okay, so it was just some extra RO data. I think what I'll probably start doing is moving entity Harpy into a shared function. I mapped all these symbols between the two versions of the game, and we can create an eharpy.c file here. I don't think we can include any stage types necessarily. Thank you, Dizik, I appreciate it. And we'll move all of this here for now, and then I only have one implementation that I need to worry about, our include for the debug. I don't have that there, but let's go grab the include eharpy. And then as entity Harpy Dagger, Harpy Flame, etc., as those get done, I'll move them into this shared file. And we can do the US version at the same time. And it should be .h. And I do want to make sure that I grab that include at the end. I thought that I did that, but I guess not. I'm gonna do a quick diff against this and the NZ1 version. NZ1 is US and NZ1 underscore PSP is PSP EU. It looks good. So I'm going to keep this here for now. I'm going to make sure that the PSP version works. Include .h. Oh, what is it? Not like syntax error on line 13. Oh, MWCC gap, why are you such a pain? Do this, that's the right one. So when it's in there, it's fine. What is going on? Screw something else up. Yes, I did, of course. I did. Oh, my bad. As the kids say. MWCC Gap was telling me exactly where the issue was, and I just wasn't listening. So that is working on the PSP. I'm gonna add all this. Now I have something working. Not worried about that so much. I would like that, but I'll have to go back and make that change again. That's the important one. That is necessary. That is necessary. All right. So now we're gonna get a clean build on US and then do the same change over there. And then we should have a nice shared Harpy that we can keep building on until we get the rest of the Harpy stuff. And then we'll move on to Cloak Dagger. What time is it? 10:30. I have a hard stop around 11:30 today. 11:30 in the best time zone. I'm both including Entity Harpy as well as defining it. So we can close all the PSP stuff for now. Nothing has changed here, so I'm expecting this to be fine. I do have a change out to fix this comma issue. It hasn't been put in yet. Hey, roaming. Love an early stream. 6:30. And that works too. So awesome. We have a matching Harpy. This is why I don't send my Discord messages earlier, because had I sent it yesterday morning, somebody else would have probably pointed out my stupid mistake, and then I would have to share credit. Who wants to share credit? I'm kidding, of course. Obviously, I'm standing on the shoulders of giants, as I've said many times before, and you all help me along the way. I wouldn't be able to do it, I think, without stream here, without chat. Let's finally, I can close out all these Harpy tabs. Come on, you can close it. You can close it. Let's go. Apparently not. Apparently Safari does not want to close the Harpy tab. I do have to integrate a bunch of this other things that we have here, but I do want to go back to this was the Cloak Knight. We have the PlayStation and the PSP version, and we were working through on Monday. We were working through the end of getting the PSP version in sync. So PlayStation version is at about 97%, and the PSP version's at 87%. Cloak Knight is the guy up in the attic who likes to cause all kinds of mischief with his sword flying around. A much more intimidating enemy than he actually is. Looks more intimidating. All right, so let's go through. There's going to be a bunch of things that I think where it was left off was getting some variables. There's probably some types that need to be fixed as well, but getting some variables removed, I think, is going to be the main thing. So there are things like this where there likely is a player pointer. I don't know if I have a player pointer yet. I don't, which is a little surprising, to go back to having a player pointer, because there are too many variables as it is. So to add another one seems counterproductive, but that looks like that's how it's written. So what can I do? We're pulling pause X right now from the stack, and we don't want to, but there's not really, the player variables getting pushed to the stack, and we don't really want that. It's possible, I should have looked here first. It's this S1 register that's getting used. No, sorry, S0 register. I should have gone to see if this is being used elsewhere. It is 43, so I'm calling this child, but it's being used as the player here. So I probably should rename this, because it is not the child here, it is the player. I could call this one just entity, and there may not be a separate entity pointer either. Maybe we just have two of these all together. And it probably is the way to do it. This one is S3. No, S0. Let's see where else S0 is being used. Unrelated. Let's find where that child 2 was on 46. So you do have S0 here. So yeah, I think we have entity 1 and entity 2 instead of child 1 and child 2. So I'm going to rename all of those and then get rid of entity and player. And so entity, I think, was always being used as Oh, maybe we just have the same register. So S0 is being passed as argument 1 here. And then down here, S0 is being, so maybe we just have entity. Let's see if we ever need child 1 and child 2 together. It's called entity 1 now. Alright, so entity 1 is self plus 1. And then we set the Z priority, and then we don't use it again. So yeah, it seems like we just have a entity pointer. And that will hopefully clear up just about everything. Sometimes I think if we knew the names for these and didn't have to come up with new names for ourselves, maybe some of this would make more sense. Here we are using entity again, but let's go down here and look at 246 in the assembly. My guess is that these are all pointing to the same thing, but maybe not. We'll see. So we have, where's our step towards function? Let's find this entity up here. This entity is getting written to S0. Let's see where S0 is being used. Some of the math here is being done a little different, possibly getting pushed to a register. We do have an S6. And where is S6 getting assigned? Oh, this entity appears to be a pointer. So I think there's a parent pointer here. And it is going to that one is going to a separate variable, it appears. And then down below, are we going back to S0 when we allocate the entity? Yep, that is going back to S0. So I do think we have two entity pointers. One of them is going to be parent, though. So I think we can get rid of entity 2 now. Entity 1, that can be gone. And player's going to be gone. I think we're going to have parent. And so where we have player, that is just going to be entity. And how is this treating us? We're a little just a little bit closer. A lot of work for just a little closer. So let's get that parent out of the way. We're going to have to create an entity extension. So this is Cloak Knight. I think I'm pretty confident that that's what that is. So let's create a Cloak Knight entity extension. And I'm not sure if Cloak Knight... I don't think Cloak Knight shows up anywhere else yet. So I think we're probably the first. Two Ks in a row. So we start with offset 7C, and we're just going to make those 32-bit values until we get to 88. So we'll be at 80, 84, and then at 88, I'm going to say that there is a parent. We have to say that the parent is a struct entity as opposed to just an entity. Yeah. Because this is a forward declaration, and it needs to be a forward declaration. We probably could do the type def beforehand. I should look into that. It has to be a forward declaration because the union is part of the entity definition, but this extension is part of the union definition, so we kind of have a circular definition of these. Let's see if that is true. So what if I take this entity out? It's gonna be dangerous. We already have our struct entity. I'm gonna get rid of the type def there. Struct entity. We should have a forward declaration. So what if I did I do that? Yeah, that works too. Now I should be able to, because the forward declaration of the type def, I should be able to use the bare entity. I don't know why we haven't done that yet. But that seems like a nice quality of life change. All of our entity extensions, so many. I don't know why I didn't think of doing that earlier, but I didn't. All right, so now we're back here. So we're going to go to, I think, we're gonna go to parent ext Oak Knight. And let's get back down to where we were, 247. So yeah, we are reading the 88th offset there. And now we're going to use this parent, set the pos x, pos y, and we're not going into the entity extension anymore. PosX.val. And yeah, we get the expected result. We're not writing to the right register, but that's okay. This is not quite right. So this isn't the parent. It's just a pointer to two 32-bit values. So this is, what would this be? A pause? Yeah, it looks like a pause. I was wrong about the type. That's okay. So let's go fix our Cloak Knight up. So we'll need a pointer for that. We do need a pointer for it. And we'll be taking a reference here. Let's look at what that so we have X and Y. And get the right declaration there. Move this up. Oh, that's so it's not called parent anymore. Now it's called pause. And now let's look and see if this looks better. So we're going to offset 88 and then taking a pointer to that field and then setting those values. So that looks much better. So here's some moves here that need to be dealt with. Writing to the stack. Let's see what our stack is looking like. Still not quite right. But do we have most of the logic appears right so far? It's just dealing with the stack. 241, something's going on there. This velocity Y is being read next to velocity X. Trying to see if there's anything that looks significantly different. I'm not worried about the difference in buttons. Macros will take care of that for us. Yeah, so just moves and stack stuff right now. So I think what the next step is to go through and try to find the same things as the other one. Are there... the two velocities look weird. These down here. Yeah, I agree. Rotate an illegal doesn't necessarily make sense. Don't disagree. So we have so yeah, velocity Y should be angle. I think that would be a better name here. And then this is like the scale or the multiply, so it does make sense. And where else are these used? Are they used? They don't appear to be. So let's rename those, and life will be a little better. Angle is redefined now. Let's see where else angle is being used. They're the same type both places. I probably can reuse scale as well. I think that's fine. And let's see where scale is being used. We do have scale elsewhere. This far as 2. That probably could be... Let's look at the step towards function, see what it calls. It calls this target. But some places call it angle. Here it is being used as the distance between this primitive and the entity. So, I mean, maybe distance is a better name for this as well than scale. Let's call it that. And then I think as far as S0_2, I think can be the same thing. I'm going to call it, if I rename it scale, that will get in the way of some field names, so I have to be a little careful. Let's call scale distance for now. Okay, and then var S0. And that might actually help with our I need I ruined all these fields. Let me go back. Didn't notice that. So these are going to be velocity x and velocity y. I guess I could just do that with find and replace. All right, and that is getting us much closer. How's our stack? Stack looks good. There are these 2 additional... Oh, that one's gone. Good. And this one? So we do have one more. This is actually that same offset, so I think we can reuse that same distance variable there. Let's look at 152. This is... I wasn't sure on the PlayStation version how this was going to be how this one was going to be written. And so I didn't even attempt to rewrite it because I knew that we would get more information here. So this does look like it is a plus equals 8. What I didn't know was whether or not we would be rereading the field or if it needed to be in a variable. Let's try rereading the field. And that looks perfect and gets us much, much closer. So both of these can go away. And now mostly what should be left, hopefully... Oh, we actually might be missing a variable now. Hopefully it's just little things like... Yeah, I was trying to figure this one out, actually. This, where the negation goes here. Let's look at M2C. With the shifts and everything, this was turning out funny. This is a different case 1. Or a case 3, case 1. So our negative goes on the 60. So we're going into a variable first and not using abs. Seems like a lot of code for very few instructions. Especially when it is just an absolute value. Could this be a... No, it wouldn't be a clamp. It looks like distance is being used for the Pythagorean distance here. Not quite sure. Oh, maybe. And then are we doing a distance times equals? That seems to be how that is being written. Sign extension usually means that something is causing this to be reinterpreted as a 16-bit value. We're doing the store and then reading it right back again, so this is an explicit check against 0 then. Depending on what the meaning of the field is. So timers are often checked with just a not. So I'm a little surprised that there isn't that explicit 0 check there. We do have an additional move here. Oh, let's try star equals -1. No, it didn't make a difference. What other ways can you negate something? Yes, that is, I agree. Roaming says on YouTube, funny that it's a check against 0 with a post decrement. So why or how do we think this, or why did I put it inline? I don't think most modern code would be written this way. We would do the decrement and then we do a separate read on that field, and it won't be array access when it's done. But if we do that, we'll see if I can write C correctly. We'll see that there's an additional load there, and we can't do that. The way that this code is written is as if there isn't an optimizer on the compiler. So the programmer themselves is doing the optimization for the compiler. But by this time in history, optimizers were already good enough if you turn them on. That's the crucial part. They have to be turned on to do anything. So I'm going to ignore this move for now and hope that something happens along the way that works it out for me, but we'll see. 133. So this line on 132 is strange. Did this not compile again? There we go. I was wondering why I was getting the wrong line numbers. I think we have some additional variables in here, and they're getting incorrectly inlined. So we do have other cases. No, we don't have any other cases where we're calling get angle between entities. We have we do have angle, so I'll try to reuse angle there and see if that ends up being a good name. And we're doing the mask pretty early. The mask is not being done right away though. So we're going to do angle and then do the mask separately. The player is getting read into a variable. This is all very bizarre. Then this keep tracking the variables here. We're going to do the subtraction right in line. No, we have the additional moves. Yeah, so I think that this is getting written back to angle. So I think this is going to be angle equals all of this. And then we're going to be doing the angle comparison. Okay, so I'm trying to work through this. Basically, getting the key is getting the ordering correct. The absolute value is taking place later. Are we doing? Oh, we're doing the subtraction right away. Okay, so the absolute value is after the rest of this. I see. And can we do that inline? Let's try to do that. That does look like it's being done inline. There we go. Yep, thank you. Thank you, Dizik. That is exactly right. Dizik called it. 148. So the stores and loads help you identify where and how each of these things is happening. So this add plus 100 is getting done first, and then it's getting stored back to the offset 1E, which is rotate. And then the and is doing it, and that's getting stored back to the rotate. 1 second, I need to take this call. Hello? Sorry, banks, kids, fraud, all that kind of stuff. We're back. All right, so this is going to be a plus equals. These rotation values are PlayStation format rotation values. Those are a little funny. You take, let's see, what is the best way to describe it? You take 360 and divide it by 4096, and that's how you get these particular numbers. Often what I see in this code in general is that even hex numbers are chosen, and so when we convert these to rotation, we can, let me get the, this is going to be actually, this one's not too bad. 22.5 degrees. Is that what you'd expect? I don't know. But then they're masked back down to make sure that they're only 12 bits, because that is. Oh, I don't have this macro, so I need to go get that macro and put it in my contents. This is uncommon. I would like to move these to, I think these should be in types. Oh, I was wrong. I put it in the wrong order. You take 4096 and then you divide that by 360. Basically, hex 1000 becomes 0 degrees or 360 degrees, and then everything else is 4096 increments between. 153. We have an additional move here. Oh, we're missing a move. So the it looks like we're calculating angle first. and then passing that in as a arg. We're getting close. I might have the wrong variable there. We'll see. Yeah, let's try distance for that one. It doesn't make sense for distance, but that might be the better of the two. Doesn't make a difference right now. So I'll keep it angle. And we'll keep going. We'll have to work out those eventually. 205, it looks like... It looks like arg1 is getting pulled out into a variable. I don't like that. Let's try it. That doesn't seem necessary. It's it's getting written to S3. No, yeah, I don't think that's what's happening. There's gonna be something else that's gonna introduce that move later. I think I'm not confident that that would be actually being used that way. 208 is using that same arg, but that doesn't make sense. Entities 256 is actually after the end of the array, so it's not a valid value, and so putting it in a var doesn't make sense. Ooh, this is actually bad. This is bad. This is a bug. This is a bad bug. And why does it work? I don't think it does work. All right, so the reason it works is because it doesn't matter, but we're writing to memory that we can't write to. Okay, so here's what I think is happening, and that actually changes a bunch of what I'm thinking. I think what's happening is we're doing this. We're grabbing one past the end of this entity array and passing it as the entity, and we're not actually assigning it back. Oh no, we are. We're assigning it to S0. So we do have another pointer. We do have another entity pointer. So this is weird. Let's do this. We need an S3. Let's go back down and where was this? 207. Decompiling is like the most thorough code review you've ever had. No, weird. Now we're taking the 224. Is that right? It's going into A1. Nope. I'm wrong about all that. Wrong about all of it. Thank goodness. We're getting a load immediate 2. All right, so the move there, not sure. Not sure. This looks like it's just, yeah, register selection. So hopefully there's something else, kind of like the other one where you change the comparison operator and everything falls into place. I'm hoping that that is the way that ends up working out and gets rid of all these other moves as well. We are missing, like I said, we're missing one variable. So unfortunately, this is something that I dislike about getting these PSP decomps working. Let's check this on the PlayStation. I think this should work on the PlayStation. I think we're missing a variable that could cause some issues, but we'll see. Otherwise, I think this will work. We need the Cloak Knight. I think I'm just going to take the whole context and then get rid of the dummy in the primitive. I think that'll be easier for now. Not a match. What a surprise. Are we closer or further? And yeah, we're missing. No, we have two little stack space here. So we are missing a variable. So let's go through, figure out where our missing variable is, and then we should be done. Actually, I'm out of time. I can't continue. So I will be back tomorrow. I didn't stream enough this week, so I'll be back tomorrow and we'll finish this one off. I do think we'll go through, mark all the registers for each of the variables, and we'll find something that's should be there and is not. We've been decompiling Castlevania Symphony of the Night, looking at the Cloak Knight at the top of the clock tower. If you want to know more about the Symphony of the Night decompilation project, go to soten.z.dev. And you've been watching Made Up of Wires, where we've been decompiling Castlevania Symphony of the Night. That's all I got. Adios.